talk about map projections. So basically, here's what's kind of tricky about maps. Yeah, it's hard when you save it all till the end, Andrew, I know. Here's what's tricky about maps. What we do when we look at a map is we are looking at a portion of something that is round, right? So when you take something round and you try to represent it on something flat, then that's very difficult, isn't it? And there's not really a good way to make that happen. I want you to imagine an orange. In fact, yeah, go ahead and imagine an orange. Yep, you have a globe right next to you. That's excellent. So I have a little cutie right here. Okay, so here's a little orange. It's round, kind of, mostly, right? It's roundish. So imagine then, if I peel this cutie, which I'm going to try to do, and I have this skin, is there any way for me to make it be one big flat rectangle? Okay, Elijah, no more speaking alien, please. I can cut it, but even if I cut it, can I make it a flat rectangle? So even if I cut it, right, like you can see that these parts go together, but there's nothing that I can do to make that be flat. So imagine now, if this is a globe and it has the countries all over it, if I try to make it flat, what's going to happen? You're right. I could, yeah, it's going to be kind of confusing and sort of messy. And I just dropped the orange on my computer. So here I have one big piece. And if this had the map drawn, the countries drawn on it, it's not going to look like the maps that you usually see, is it? Right here, it's kind of a plus sign. So that's the catch. That's the problem that we have when we have a map of the world is this circle, a circle, or a globe, a round sphere is the actual shape of our Earth. But when we're trying to represent it on something flat, is there any way to do that absolutely with absolute accuracy so that it's exactly right? There really isn't, because you're trying to take something round and convert it into something flat. And because there's no, then you wouldn't see the other side. So like this, I have the entire peel right here, which is great. But then when we make it flat, it's going to be all kind of cattywampus. Okay, don't get too far ahead of us, Molly. So, right, so it's going to be a problem to try and get it so that it can be flat and easily read. So in order to then give a flat map of the world, there's going to be some kind of distortion. Something about it is going to be not quite right as we work hard to try and represent something round on something flat. And so when we do that, when we create maps that represent something round on something flat, because there are different ways to do that, we call them projections. And each projection has something that's really good about it and something that's not quite good about it. Molly was just talking about goods interrupted projection. And you can see that on page 24. Do I have a... Here's goods interrupted projection. And this is sort of like the orange peel, right? Where it really does show the shapes in a less distorted way. But what's the problem with that projection if you're trying to use it actually to measure things or figure things out? What's the problem with this particular projection? Okay, bonkers, right? Andrew says it's bonkers. What do you mean by that? It's bonkers. Why is this not a particularly usable one? Okay, it looks crazy and unnatural because it's split into sections, right? And to have it split into sections, right, you can't see all of the ocean all together in one place. It makes it look like to get from one place to another, you'd have to take a big leap across space. So when you look at this, your continents are the proper shape and then they're proper size, but it would be very hard. You know how we talked about our not our index, not our legend, not our key. What's the mappy word that I'm looking for, you guys? That tells how, yep, that's the mappy word, Claire, thank you. So we talk about a map scale. How would you do a scale on this map? It would be very hard to even have a scale. If the scale was accurate for this area right here, it would still be hard to figure out the distance from the United States to Europe because you have this big break in the middle. So goods interrupted projection is great for being able to tell what continents are larger than another or exactly what shape they are, but it's not very practical, right? So then let's look at some of the other options that we have. The first one that we talk about is actually the Mercator projection. So the Mercator projection is flat, and this is one of the oldest and more popular projections. It has true shapes of the land areas, but the sizes are distorted. Looking at this picture right here, what continent do you know for sure is distorted? It's not the right size. Good, Andrew, that's right. Antarctica is very distorted. It looks a lot